You see my screen as well?
Yes.
Excellent. So I can start. I have opportunity to finalize this day, and the first speaker was our rector, and I will continue. And greetings from Ventspils. I tried to discuss question about variability of active galactic nuclei and free with species Perseus alpha, Markarian 421, and Markarian 501. Joint radio-optical observations, which was done together with Ukrainian, Slovakian, and Latvian consortium in this case. This activity started in 2017 in Ventspils begin, and first we have collaboration only with Odessa Observatory, but later we found out that radio observations, it's very interesting to join with optical one, and we start do collaborative work together with optical observatories like Baldone and Viharlat Observatory as well. But first of all, about instruments, what we are using in our study. So it's three antennas. First antenna A is 32 meters antenna from National Space Facilities Control Test Center, Ukraine, located in Zolochiv. This is old telecommunication antenna converted recently in 2020 to radioastronomical instrument, and we was very lucky to have more or less exclusive access to this instrument before it starts full scientific work, so it's in preparational stage. And we also use our antennas, 16 and 32 meters antennas. And additionally, as I told, this work was combined with optical data from Baldone Observatory and from Viharlat Observatory and some more Ukrainian telescopes, smaller sizes. And interest of our study is to find fast intraday or intranight variability of active galactic nuclei in Perseus and Markarian objects. And question is what these objects are supermassive black holes, and potentially we have binaries, so it's two supermassive black holes rotating one another. And previous studies show that we could find even intraday, so several hours of periods or fluctuations in brightness, which means we have objects which is around a solar system of size at distances of hundreds of megaparsecs from us, and with distances in local space around 2000 parsecs sometimes. So it's very compact and very intriguing object, and we was lucky to have access to radio and optical data provided by our instruments, and we have a lot of observations in 2000 and 2021 in radio. So it's around 90 days in Zolochiv telescope and around 270 days in Latvia here, tens of days in Baldone, Slovakia observations, and also interested observatory, so it's a private observatory called Heavenly Oval, owned by Valery Semestrinka, which also participated in these observations and provide the data from this telescope, which was quite interesting for us as well. And we use telescope in radio band. It covered from 1.6 up to 8.8 gigahertz range, so several frequencies in both places. In optical, we have a set of data in optical and B, V, R, and E filters. So we have plenty of different kind of information and different spectra, and we study these three objects. Why is these three objects? Because they're very interesting, and one of idea to find out what physics can make such fast intraday variability, and this is main goal of our experiment. So we also use historical data and measurements since 60s, and as you can see here, for example, Perseus Alpha or Galaxy 3C84 have very nice periodicity, which you can see here. But this is in years, so it's around 40 to 90 years period. And also from right, it's radio structure of this object and radio lobes. And what we did, we tried to observe in radio. And as I told, Zolochev telescope was just started observation. And first, it was also technical part. So we need to adjust for all parameters of observations, like remove noises, remove daily and elevation trends. This was also done for this telescope and for Urbana as well. And next step, we try to find what kind of potential periods could be in this data. And as you can see here, this is wavelet spectrums of observation in different frequencies. Here is 5 gigahertz and 6.2 gigahertz. And some evidences of like around 1 hour, 3 hours, 4 hours period. And so it's clearly shown with this. And same different observations in different channels. Again, 8 hours periods in data, 1.5, 3.5 hours. So it's very fast quasi periods what can be found in observation. We try to make also some kind of analysis of what could be this period, and here one possible question. So if this period come from source itself, or it's arised by some, for example, quasi-periodic ionospheric acoustic gravitational gravity waves occurred in ionosphere and influenced to our data, or some kind of fields between our galaxy and this object. And potentially 1 hour and 8 hours of periods, it seems to be not exactly source itself, but some external influence of recorded signal. As you can see here, very bright 1 hour evidence of periods, about 99.9 threshold. Same for 8 hours. So, and this also taken in account Zolochev data and our data in Urbana. So we're speaking about radio. So some examples of radio observations conducted in Urbana in several frequencies. Unfortunately, we was not able to make a purely simultaneous observation. So we have joint observations, but each observations are not exactly in time with, for example, Zolochev and Urbana. So we have only a couple days of overlapping. So some technical problems, stuff, scheduling of telescope time, and so on. And we can't say exact simultaneous observations are not so much here. And some additional evidences of periods what was captured in VIRAC data in October 2020. Again, 8 hours, 6 hours, so it's different frequencies. So it's 8.7, 6.1, 6.7, 5 gigahertz, but all frequencies show similar periods in data. So it's quite good evidence that these periods are existing, but still it's not guaranteed that this comes from object itself. So currently we assume it's mostly ionospheric fluctuations maybe. Intriguing questions. So we also found some similar 1 hour periods in 1.6 gigahertz data. So it's quite big change in frequency, but still similar period, quasi periods here. Similar 1 hour variations also found by Chinese colleague from Yunnan-Chi telescope for object 3C273 and 5 gigahertz. So again, it looks that this kind of periodicity could be influenced by not object itself, but close ionospheric fluctuation. So I probably not continue in conclusion. So we definitely found periods here, but it could be defined what kind of physics rises evidence. And this object is definitely variable in radio. They have fluctuations in intraday, intra-night time scales, but difficult to say if this is a periodic or not. Optical and additionally, so we have a lot of optical data, as I told. For example, here, example of data from Slovakia, so Viharlat Observatory, taken from October to April 2021, and Mayaki, Ukraine. So here is not evidences of very bright like a fluctuation, but still some small scale amplitude fluctuations around 0.5 magnitude or about but around 0.7 with days time around 14.9 days, for example, or we can find such kind of variation. So it's not intranight, but several days fluctuation. And if you look for least squares parametric reconstruction and try to find out some crazy period by sinusoid, we clearly see around trends in 450 days trends, so around 45 and 70 days periods or quasi periods in this object, again in different filters and different observations. Very nice sample of example of data from Baldone from 3C48, which also very quality data, but not evidences for real periods of fluctuation, periodic fluctuation. So some of fluctuations what could be found is one good evidence for 11 of October in 2021, about 10 hours of characteristic period, and again 1 hour of period as well. So additionally, so it was make analysis in such a way for Viharlat and Mayaki Observatory from Ukraine, and find similar variations. So small variations with typical 40 days, for example, or 40 days, yeah, 40 days period. If you're looking for long-term variability, here is much more clear evidences for fluctuations and some periods. You see here yearly scale, so it's 18, 44 years and 1.6 years of potential quasi-periods obtained from historical data. which is agree with physics of this object. They are variable and variable in yearly scales, but in this case not very new result in this case. So we just repeat results from the previous authors. And going to another source, which we take for comparison of Perseus, so it's Markarian 421. It's a BLAC object, very bright quasar, emitting from gamma rays up to radio. And again, some example of Mayaki and Viharlat data and at VRI filters. And for this object, we see periods in days, around 9 days and 10 days, which have a good fit. And additionally, we can compare these observations with light curves obtained from American Station of Variable Star Observation catalog, so AAVCO data. In V-filter, they have similar evidences for 12 and 28 days of some kind of quasi-period. And some example of light curves for long term. So it's black is optical and light curves in V, R, and E in color. And nice periods in years for this object, which also obtained for historical data, which is quite clear, about 1.6 years. Similar study was done for Markarian 405, which is very interesting, same BLAC object, same type. And as I told, here was very interesting collaboration with amateur observatory. So it's telescope around 48 centimeters near Odessa, but provide very quality data which we use in our measurement. So same slight periodicity in this object in all filters, in all bands, optical bands. And we found again around 10 days and 49 days, for example, 14 and 36 days in several filters, which very close one to another. And in parametric reconstruction, we see, for example, here 43 days of period. So this study, it looks very interesting, and this was funded by Latvian Consul grant, but very short, 1 year project. Currently, we continue with studies just by our own resources, and we saw what this kind of observations, optical and radio, and international collaboration can give very interesting and bright results, which could be continued, and I hope it will be continued in more intense way. And thanks to Ilmas Eglītis for Valdoni data again, and currently we try to make it more intensive, adding also European WLBI network, so mapping of this object, and try to make it not only full power or intensity data, but also imaging and get structures and try to find potential changes in structures and find out if it changes, fast changes occurs in core region or in Z system, because it's still unknown and still could be a question of study. Yeah, I think I take all my time, and thanks for inviting me. So, and maybe you have any questions. So,
thank you. We have a questions. I don't see. Then thank you once more, Vladislav.